Hello everyone, my name is Zhen from Alibaba Cloud, and my co-presenter is Kang from Alibaba Group. Today we are very glad to share with you how to use StarRocks and Paimon to build a near real-time streaming lakehouse, and we'll also show you some use cases at Alibaba Group. In the first part, I will introduce how to build a near real-time streaming lakehouse in Alibaba Group. And this picture shows the Lambda architecture. It is a typical big data setup in companies for the last 10 years, which is built with tools like Hadoop and Flink. And basically, it is split into two main parts: offline data warehouse and real-time data warehouse. We pick one or the other depending on the data freshness we need. Offline data warehouse is usually for the scenarios with T+1 data freshness, and in contrast, real-time warehouse is for scenarios with second-level data freshness. However, this setup has several pain points. First, you should maintain two sets of code, which is a burden for the big data engineers. And second, it doesn't support transactions. You cannot easily do small updates, and actually you must update data with some heavy operations like insert overwrite, which will rewrite the whole partitions. And third, scaling up is very tricky, because all the metadata is stored in one central place, like the head meta store, so it can be a bottleneck as your data grows. And also, query performance isn't great, because head meta store can only provide partition infos and lack 5-level metadata or indexes. The metadata is pretty simple and coarse-grained, so it's very difficult for the compute engines like StarRocks to make optimization. Lakehouse is becoming more and more popular in recent years, and it combines the best parts of data lake and data warehouse, just like building a warehouse on top of the lake. It provides a variety of tools for analyzing and managing your data. It has several advantages. First, single source of truth. And I think this is the most important advantage. In the traditional data warehouse setup, you should first make several ETL operations and then ingest your data into different warehouses, which may lead to data silos. And now, in Lakehouse, you just ingest your data into the cloud storage. And everyone actually agrees on this version of data, including BI and AI data. And second, it offers great support for transactions. It handles ACID transactions well, and you can make fine-grained updates without overwriting the whole partitions. And third, because Lakehouse format is stored in cloud storage like S3, it can find files from metadata without the expensive and slow list operation. And finally, powerful query features. Lakehouse format provides many excellent features like MVCC, time travel, schema evolution. For example, it's very convenient for you to rewind your data or correct some invalid data. Lakehouse format also provides 5-level stats, so it's very easy for computing engines to leverage data skipping such as predicate pushdown or columns prunings, which can increase the query performance a lot. And when we talk about Lakehouse formats, 3 names are very familiar to us: Apache Iceberg, Data Lake, and Hoodie. Because they are not our focus today, I just listed comparisons here in the table and will not dive into the details. While each of the 3 has its own advantages, they share a fundamental issue. They are all designed for batch processing and are not suitable for real-time scenarios. Because as data grows, we cannot make minute-level updates. And to introduce a near real-time streaming lakehouse format, Apache Paimon has emerged. Over recent years, as a next-generation streaming lakehouse format, Paimon's community has developed very fast. Let's quickly go over the core features of Paimon. Paimon combines the LSM tree structure with cloud storage. This enables high performance, low latency data ingestion, and we can make efficient updates or upserts. Paimon also can easily generate change logs for stream read, which is essential for Apache Flink. And when it comes to the near real-time scenarios, Paimon can provide a cost-effective way of minutes-level data freshness. And Paimon offers native integration with Apache Flink and also is built for open ecosystems. It has integrated with major computing engines like Spark, StarRocks, and Presto. And in essence, Apache Paimon not provide traditional features of Lakehouse format such as ACID, time travel, schema evolution, but also designed for minutes-level streaming data process. And this picture shows a typical real-time data pipeline with minutes-level freshness. We use Flink for streaming and Spark for batch processing to handle ETL operations across ODS, DWD, and DWS layers. And the final processed data then loaded into StarRocks for analytics at the ADS layer. Meanwhile, StarRocks can query Paimon lake tables directly. So as we see, StarRocks and Paimon can perfectly work together. So as a conclusion, as a modern SOTA-designed OLAP engine, StarRocks delivers high-performance queries across all data tiers. So this is all my part. And next part, my co-presenter Kang will share with you some real-world use cases of StarRocks and Paimon at Alibaba Group. Thank you.
Hello everyone, I'm Kang. Let's launch into the application of StarRocks in the context of e-commerce instant retail. We can see an introduction to the background of flash sale. So Top Flash Sale is a marketing initiative launched by Taobao, an e-commerce platform in collaboration with Alam, a food delivery platform, amid the rapid growth of instant retail industry. By aggregating resources for the brands, it offers our users getting the content product or exclusive promotion through time-limited flash sale and limited quantity supply mechanisms. For example, we can see from the picture below. Users can select design food or product within a very short time frame via our e-commerce app, and will then swiftly deliver them to the customer through this via the delivery platform. And for the business operators, it is essential to have real-time access to critical information, such as payments and orders, to facilitate operational decision-making and adjustment. This leads us to technical background on the page. So, data-driven decision-making and has become a core competitive advantage in the modern business landscape. Previously, Alam's data infrastructure relied on the latency of live processing. The latency in analyzed results made it difficult for our business owner to capture real-time semantics and to gain minute-level decision support. With massive data flows, the challenge for traditional systems is to collect, to clean, analyze, and visualize data within minutes. So to address this challenge, we introduced a real-time data lakehouse using StarRocks and Paimon, achieving a transformative upgrade in master data analytics capabilities. This solution has three features. First, it uses Flink to build Paimon lakehouse data as storage foundation. It is LM3 architecture to enable real-time data rating with automatic deduplication and aggregation. Second, while StarRocks external catalog, we can directly query payment table data. It eliminates the delay associated with traditional ETL processes, achieving unified query access. Third, through feature optimization for the Lakehouse scenario, such as the implementation of deletion vectors native for payment, we have achieved a tenfold performance improvement in StarRocks query response time. So building on this architecture, we encounter some challenges during the implementation, but also achieved significant improvements in real-time analytical performance through technical method. And first, optimization tools is materialized view. So in the early state of flash sale, StarRocks Paimon met our base needs of data freshness, but as the business exponentially, real-time analytics bottlenecks appeared. At our peak traffic time, complex queries slowed down from second to minute, and data brought refreshes was heavily delayed, and this direct affect our decision making. So to solve this problem, we built an optimization framework with StarRocks VMB. The first optimization was for BI dashboards. As a user-based screen, scaling resources with larger cluster began to affect stability. To address this, we apply MV to a dashboard query between StarRocks and Paimon, and this refresh every 10 minutes, speed up queries while reducing this pressure from large-scale query on the clusters. The second optimization was for long-set queries. After going live, business operators need metrics such as daily and weekly comparisons, which required longer term data storage. So to address this, we added a network of line insert task to load the previous data into StarRocks internal tables, and then combine real-time data with history of line data into a visual view. In this way, we could aggregate both real-time and offline data at the finest level and optimize query performance. For the third optimization, we use StarRocks 3x3 along with partition memory and multi-base table partition alignment for payment Lakehouse tables. We replaced the MV for the first optimization with partition MV to support historical data storage. By this, we can simply use partition by to match the base table's partition field. Compared with earlier method, the greatly simplify operations. However, if the lake table life cycle shortens, the MV will also drop corresponding partitions on the next refresh. So if the view needs to retain data longer than this base table, alternatives are still required. From our practice with MV, we found that for complex real-time scenarios. They work best as data acceleration at ADS layer. The ETL process from DW to ADS should stay in Paimon. Keep data flowing in the data lake. With StarRocks and as a final query accelerator. To feature optimize, we explore using RoaringBitmap in the lake to solve large-scale injective deduplication. This hypothesis use cases like code drawing down weight to pressure rate calculation, and long cycle traffic matrix. By querying RoaringBitmap data in Paimon directly with StarRocks Bitmap function, we greatly improve data freshness and query performance for real-time UV and multi-domain analysis. So let's first review the difference between traditional duplication and bitmap duplication. On the left, we can see the traditional duplication processes with 6 rounds of data across 2 nodes. Since the data must be shuffled multiple times, computation costs rise and query slow down as volume grows. On the right, we can see bitmap duplication. Each dimension only is one UID bitmap. Deduplication is done by bitwise or operators across bitmap, then counting the number of swans to get the UV result. In large-scale scenarios, they support with significant storage compared with UID-based duplication. However, when a dimension is sparse, most of the bitmap contains 0, which means invalid. It would waste over space, and that's why we will use RoaringBitmap to solve this problem. Let's first look at an application scenario for RoaringBitmap. Multi-dimensional real-time UV in the traffic log, and the later state of the flash sale project. The business requires more flexible multi-dimensional real-time metrics across various channels, including flash sale and no-flash sale data, and the previous approach, which directly accelerates lake table DW with MV, struggle to meet these flexible needs. And additionally, multilateral competing for resources cause MV refreshes to become less timely. So to address this, we use the RoaringBitmap along with Paimon streaming read and write capabilities to calculate multi-dimensional real-time UV. The solution was shown in the diagram and involves several key steps. The first step, we map UIDs to integer type in real time using an auto-incrementing sequence. And second, we deploy Flink UDF function that supports bitmap AGG and bitmap unit operations, returning the results serialized as bytes. And third, we integrate tables from other data warehouses, such as city tables and user segmentation tables. The first, data from the method-oriented middleware is ingested in the lake and use Flink circle to read payment detail data in stream model. Conducting lookup jobs with the UID mapping table and other dimension tables. The fifth, The bitmap agent function converts the map's UIDs into bitmaps and syncs them into downstream lake tables. And 6. Depending on the business scenario, we use StarRocks Bitmap unit count function to compute real-time duplication count as required. And finally, if multi-day trains are needed, we can feature unit bitmaps to create hour or daily bitmaps. And next, we move to second application scenario for RoaringBitmap, multi-domain bitmap usage. In the later stage of the project, the business frequently change user segmentation criteria and select new crowd groups for drawing down analysis. So technically, refreshing dimension tables cause significant fluctuations. So we decided to separate the crowd dimension from independent processing. Additionally, we explored new business ideas, how to build a real-time bitmap data asset covering all dimensions in traffic domain, and whether we should include other domain data to calculate real-time visitor to purchase rate. Based on this exciting solution, we then attempt an alternative data modeling approach. The first, we can deduplication layer in the middle with a freshness grid. Let it aggregate data, then produce bitmap for common and single dimensions for downstream. And second, we keep the UID mapping tables, but remove all other lookup drawing tables. Instead, performance drawings only at the application layer. And third, we use branch processing for the use dimension tables, constructing core dimension bitmap lake tables, and compute the intersection for future code drawing downs. And first, and we added retracted stream processing in the UDF to support updates, and also convert older domain lake table data into bitmap. Okay, thank you all for listening. Thanks, teacher Chen Fan.
Oh, sorry, I was muted. Okay, so the question, sorry, yeah, I just said, please scan the QR code, and yeah, I just read the question. Yeah, so for this question, Anton, with metadata, performance issue, yeah, so Iceberg has the most sophisticated metadata caching design. So two layer, right, with other optimizations. Paimon does not have that, So yeah, so this performance gap is expected, and I think there are roadmaps to to make it faster, right? So I think in the meantime, it's really not that much you can do to go around that. I think um, you could move to a faster meta store if that's possible, right? Uh, but but we have to wait for the optimizations to come in or use Materialized view uh, in that regard. Appreciate that. Sorry, I was muted in the beginning. I just read the question. Okay, appreciate that. I think it's time. Yeah, if you have other question, please ask in the channel in the Slack channel. StarRocks Summit Slack. Uh, thank you everyone for joining. See you guys again in the next one. I think we have had half an hour break, and then we start the afternoon breakout sessions. All right, appreciate that. Thank you. See you guys again next time. Thank you. Enjoy. Thank you.